Two squares BAXY and CBZT are drawn on the outside of a regular hexagon ABCDEF, and two squares CDPQ and DERS are drawn on the inside as shown. These are the squares that are drawn on the inside, and the squares drawn on the outside are these. So we have to prove that PS, this is PS, equals YZ. So if I were to draw it in a better way, that's PS, and that's YZ. So yeah, sorry, it's a triangle. So that's YZ. I've joined the points. So now what we have to prove is that PS equals YZ. Now if you notice these the lines PS and YZ, you see they are part of two triangles. So this is the triangle they are part of, triangle PDS and triangle BYZ. So to prove that PS equals YZ, all we have to do is we have to prove that triangle PDS is congruent to triangle BYZ. So once that's done, then PS would be equal to YZ. So how will we prove that the two triangles are congruent? So we are given some, we are given some basic things. That the starting thing is a regular hexagon, and if it is a regular hexagon, you see all sides are equal, so that means CD would be equal to DE and would be equal to BC, and BC being a side of the square equals CT equals DZ equals BZ, and again BC equals BA, and therefore BA again being the side of the square, BA is equal to AX equals XY equals BY. And also if you look at the other squares that are inside, you have DE is equal to DS, and DE is also equals to equaling ER. So the sides are equal, and that would be equal to SR and PQ and CQ. And so the sides are equal, so the squares are all sides equal, the squares are equal. So what that means, so we can write it down, that since it's a regular hexagon, since ABCDEF is a regular hexagon, so we can say CD equals DE, and that equals ER equals DS equals BC equals CT equals BA equals AX equals BY equals BZ, and so on. A regular hexagon, and BAXY CBZT, CDPQ and DERS are squares, right? So once that is done, now you see we in these two triangles, that is in triangle DPS and in triangle BZY, in these two triangles, you see the two sides are already congruent. So we didn't write DP, we should write equals DP, equals DP as well, because DP is also congruent. DP is equal to DS and DS, yeah, and DS equals CD, DS equals DE, more like that. So it is, so what we see is these two triangles, they already have two sides equal. So we can say that in triangles, triangle DPS and triangle BYZ, DP equals DS and DP equals DS equals BY equals BZ. So we have two sides equal. Now if we can just find the including angle, then we should be able to prove the congruency. So what is this angle? ZBY. So you see angle ZBY would be equal to, you have the interior angles of a regular hexagon R. So you can work it out. Interior angles of a regular hexagon n minus 2, that's the number of sides, times 180 divided by n. So here that would be n equals 6. So 6 minus 2 divided by 6 times 180, or 4 out of 6 times 180, 3 times 60, that's 120. So interior angles of a regular hexagon are 120 degrees. So, and this is a square, so that would be 90 degrees. So we can say angle ZBY equals 360 degrees minus 120 plus 90 plus 90, and that equals 360 degrees minus 120 plus 180, 360 minus 300. And that is 60 degrees. So we get this is 60 degrees. Now if one angle is 60 degrees and triangle ZBY already has two sides equal, so triangle ZBY is triangle ZBY is equilateral. Because the other two angles have to be 60 degrees, because you see 180 minus 60 is 120 and 120 divided by 2 is 60. So all these angles are 60 degrees. So triangle ZBY is equilateral. Now we have to find, that's sorted, we have to find angle PDS. If we can find angle PDS, what is angle PDS? Our job is done. So angle PDS, if we can assume that angle PDS is B and angle R, or I say angle PDE is A and angle SDC is C. We can have that. We can assume these because we don't know. So if I say and we can write, since we know the interior angles of a hexagon are 120 degrees, so we can write that A plus B plus C equals 120 degrees because angle EDC, this angle, that's the interior angle of the hexagon. And also we can write now angle A plus angle B is 90 degree. So we can write A plus B equals 90 degree. The reason is EDSR is a square, and also B plus C is 90 degrees because PQ or PDCQ is a square. PDCQ is a square. So we have two equations here, and if we add these two equations, if we add these two, we would get A plus 2B plus C equals 180 degrees. And so we can see that A plus C equals 180 minus twice of B. So if we use this, A plus C is 180 minus 2B in this equation, then we can probably find out what B is. So let's do that. Then it would be A plus C. So A plus C is 180 minus 2B. So we can write this as 180 minus twice of B, that is A plus C. Instead of having A plus C, I wrote 180 minus twice of B and plus B, and that equals 120 degrees. So we get minus B equals 120 minus 180, and minus B equals 60 degrees, minus 60, so B equals 60 degrees. So we know that this equals 60 degrees. And once we know that, it's done really. We don't need to find out these angles. Angle DPS and angle DSP, we don't need to find these angles out because it's obviously going to be 60 degrees. So we're not going to write about it. But our proof is done. So once this is 60 and we know that DP equals DS, so obviously this, I don't know why I said that, but yeah, no, I said the wrong thing. Yeah, so because both triangles are equilateral, so and the sides are equal. It's not just because equilateral, it's because DP is equal to BY. This step we said this, that DP equals DS equals BY equals BZ. So both triangles are equilateral and congruent. So once we get that, we can say triangle DPS is congruent to triangle BYZ. So we can say SAS congruency. So we say that PS equals PZ. PS, not PZ, sorry, PS equals YZ. So PS equals YZ. And our proof is done.